Welcome to clickmyproject.com. Yeah, now let us discuss about the Waveguide-Fed tunable Terahertz antenna based on hybrid graphene metal structure. Yeah, let us discuss about the abstract of the product. So, graphene is an allotrope carbon in the form of two-dimensional automatic scale hexagonal lattice in which one atom from each vertex. So, it can also be considered as an aromatic molecule, the ultimate case of the family of flat polycyclic aromatic hydrocarbons. So, graphene and its band structure and Dirac cones effect on a grid on the doping. Graphene has many unusual properties, so it is about 200 times stronger than the strongest steel. So it conducts heat and electricity very efficiently and is nearly transparent also. So here in this proposed work, we design a terahertz, that is 10 power 12 hertz antenna by using the transparent graphene metal structure to increase the frequency of the antenna. So that is easily to increase the frequency of the antenna, and then the transparent graphene metal structure is used to operate multi-frequencies. So it's operated at a multi-frequency from 5 to 8 terahertz of the antenna. So the transparent graphene material is a single linear material used to estimate the wider bandwidth of the process. So here we using the graphene. It's a zero band gap semiconductor with complex conductivity tuned by external and internal also. So the dielectric, here we using the dielectric substrate is silver, that is mentioned by Ag. So the dielectric constant is 1 is the dielectric constant. So finally we calculating the radiation pattern, directivity, return loss, PSWR, bandwidth. So and then also the proposed antenna are calculated by using the HFSS 13. So that is a high frequency structure simulator of the software. Yeah, now let us discuss about the flow diagram of the process. So that is a high frequency structure simulator. So first of all, open the HFSS software. So that is a 3-dimensional software, X, Y and Z axis. So create a new project design. So first of all, we create a new project for the design and then substrate model in design. So here we are using the that is a silver substrate. So that is a AGS software. So using the AG software and then select patch model. Here we are using the T-patch antenna for adjusting the 3 layer of the substrate. So to design the top and bottom. So top means that is a patch and the ground means that is a bottom means that is a ground. So assigning top and bottom antenna, here we are using the perfect T, that is a perfect electric field, and then excitation. So here we are using the excitation is a waveport excitation, and then to set up the analysis. So in this analysis setup, here we are using the start and stop frequency. So start frequency, here we are using the 5 to 8 terahertz of the antenna. So all the design is implemented by the terahertz. So terahertz means 10 power 12 as a frequency. To assign the frequencies for whatever it may be, so it is calculated as a particular frequency of the wavelength. To assign the vacuum boundary for the radiation to prevent from the external activities of the antenna. Finally get the results like radiation pattern, return loss, 2D and 3D pattern of the antenna. So here we using the, so this is side wing representing the lattice of antenna. Here we using the top patch antenna and then bottom in the ground plane, and in the middle layer it's to act as a substrate of the process. So these are the 3 types of antenna. So these are the parametric studies. So width of the ground and substrate is 1000 micro mm. Micro mm means that indicate as a 1 mm. So length of the ground and then height of the substrate, T patch length and then T patch width, and also a dielectric constant of the silver substrate of the particular antenna. So this is the HFSS window of the process, and then finally we design the, so this is the value. So axiom multi-frequency by using the transparent graphene material from 5 terahertz to 8 terahertz of the antenna. So these are the overall process of the particular process. So in the designing procedure, we design the work done. So design settings, 3D model, boundaries, mesh operation, optometrics, radiation, excitation and analysis setup. So these are the overall running of the process. So the generally patch antenna consists of 3 layers. One is a substrate, patch, ground. So substrate in the middle layer, patch is in the top layer and ground is the bottom layer. So the substrate is a sandwich between the ground and patch. So it forms a patch antenna and dielectric medium of the process. So overall, finally get the results as a return loss, radiation pattern, VSWR, bandwidth, and then 2D and 2D dimension of radiation pattern. So overall running procedure, overall flow diagram of the process. Yeah, now let us discuss about the running procedure for the process. So this is the HFSS antenna design window. So here we are using the T slot patch antenna. So this is like a 3D dimension. So here we are using 2 process. One is a two dimension of the, so this is the transparent graphene and this is the patch. So here I'm using this two layers. So this is the second layer, this is the first layer. So first layer is so here we're using the two layers. One is a transparent graphene layer and another one is a graphite layer. So this is the graphite, this is the graphite layer and this is the transparent graphene layer of the process. So these are the two types of process. And then here we're using substrate is a silver substrate. So this is silver substrate and then sheets. So I will perfect T field. So that is a ground and patch. So here we're using the patches, T slot patch and now of the process. So this is the ground of the process. And then wave port, here I'm using as in coaxial feed of the probe. So this is the material. So here I'm using the great excitation of the process. So the vacuum, the outer conductor is a coax, and then in the inner conductor pin coax pin, and this one is a probe. So these are the three processes of a particular process. And then the boundaries, perfect T1 is a patch, perfect T2 is a ground plane of the process, and then radiation 1 is a vacuum box of the process. So in the excitation, here we're using the wave port excitation under of the ground, and then analysis setup, here we're using a 6.4 terahertz, and then sweep is a Addons 1 to 8. And then finally get the result. So this is the validation checkbox. So all the values, design setting, 3D model, boundaries and excitation, mesh operation, analysis setup, optometrics and radiation. So all are is correct. And then this is the analysis. All to click this file, the program is running. So finally getting the results like whatever it may be calculated, radiation pattern, return loss, VSWR should be calculated for the process. So here we are choosing this results of the process. This is the written loss graph of the plot. So here I having M1 is a minus 20 dB. So here I have changed the multi-frequency of the plot. So this is the written loss, and then VSWR. So this is the VSWR of the particular plot. So whatever it may be calculating, the VSWR is calculating. And then this is the 3D, that's the 2D radiation pattern. Here I will select this so 0 is achieving the frequency. So here I will click the results, HFSS results, great emerald and rectangular plot. So I am using the written loss of the graph. So and then overall graph it should be assuming. So this is the design, whatever it may be I will design. So these are the 2D and these are the 3D tablets of plots. So these are the overall running procedure for the process. Thank you for listening this video.